An absolute value equation is an absolute value, or it's an equation that involves an absolute value. So remember, the definition of absolute value is the distance a number is from 0 on the number line. So the absolute value of 3 is 3, but also the absolute value of -3 is 3, because they both have a distance of 3 from the number line. So when you solve an absolute value equation, what you want to do is isolate the absolute value and then break it off into two equations, because inside here could be an 8 or a -8, because the absolute value of 8 is 8 and the absolute value of -8 is 8. So at this time I already have the absolute value isolated. So I'm going to break it up into two equations. I'm going to break it up into 2x plus 1 could be 8, and then 2x plus 1 could be -8. So solving, I'll get 2x plus 1 equals -9. X could be -9/2, or x could be 7/2. Okay, both of these numbers, that when you plug them in, they'll work for x. So for the second one, I want to get the absolute value bar by itself. So I'm going to subtract 4 from each side first. So I have the opposite of the absolute value of 2x equals 4. And I need to get rid of this opposite side. And this is like having a negative out front. So I'm going to divide both sides by -1. And I'll get the absolute value of 2x equals -4. So can you have the absolute value equal a negative number? Can you have a distance equal a negative number? You cannot, so it's no solution. Okay, third one. Trying to get the absolute value by itself. So what you want to do is multiply both sides by 3. So these will cancel out. So I have x minus 6 equals 6. So the number inside here, this has to be, the absolute value of this is 6. So remember, the absolute value of -6 and 6 could be 6. So I need to break it up into two equations. So x minus 6 could be +6, and then x minus 6 could also be -6. So I'm going to solve for x in both, and I get 12 and 0. So 12 and 0 would both be my solutions. Okay, next one. Absolute values you never want to distribute, so you need to get rid of the 3. So if this is 3 times this, I'm going to divide. So I got 2x plus 5 equals 4. So I'm going to break this off into two equations. So 2x plus 5 equals 4, and 2x plus 5 equals -4. So solving for each, 2x equals -1, x is -1/2, or 2x equals -9, x is -9/2 if I divide both sides by 2. So many times there's two solutions. Okay, this one, I want to get x minus 1 by itself. So I need to subtract 8 first. I need to do order of operations backwards first. So I'm going to add and subtract first. So I have 6 times x minus 1 equals 8. So again, you want to isolate the x minus 1. So I'm going to divide both sides by 6. So absolute value of x minus 1 equals 8/6 reduces to 4/3. Or I can write this as a mixed number, 1 and 1/3. So two equations. I have x minus 1 could be +1 and 1/3, or x minus 1 equals -1 and 1/3. So adding 1 to each side gives me x could be 2 and 1/3, or add 1 to each side, x could be -1/3. Okay, and the last one, I'm going to divide, so I'm multiplying both. I'm dividing, so I'm going to multiply. So I have the absolute value of x equals negative 50. And you can't have the absolute value equal a negative number. So this is going to be no solution. An extraneous solution. So extraneous solution is a solution from an original equation that has a number, not a solution of the original equation. So an extraneous solution is you're solving for x, you're doing the motions, and then when you check your answer, it doesn't work. Okay, the left-hand side doesn't equal the right-hand side. So let's look at this one first. So the absolute value is by itself, it's isolated. Okay, there's nothing around here on the left-hand side. So what I'm going to do is, I'm going to follow the same procedure as I did above. I'm going to have 2x plus 3 equals positive 3x plus 2. And then I'm going to do 2x, a second equation, 2x plus 3 equals negative 3x minus 2. I'm making both of those opposites. So by solving for x on this side, or this left-hand one, I'll get 3 equals x plus 2, okay, because 3x minus 2x is 1x. Subtract 2 from each side, and I'll have x equals 1. And if I solve the right-hand side, I'm going to add 3x to each side. So I get 5x plus 3 equals negative 2. Subtract 3 from each side. 5x equals negative 5, x equals negative 1. So I have two answers, 1 and negative 1. So what I'm going to do is, whenever you have an absolute value on one side and you have a variable, the same variable on the other side, you can come up with an extraneous solution. So an extraneous solution means that one of these may or may not work, both of them may not work, so I'm going to actually try it. So I'm going to plug in 1 and see, in the original problem, does the right-hand side equal the left-hand side? So 2 times 1 plus 3 is 5. So does the absolute value of 5 equal, this will be 5? Yes, it does. So this means that x equals 1 as a solution. And now I'm going to check negative 1 and plug it back into the original problem. It's really important that you plug it into the original problem. So does 2 times negative 1 plus 3 equal 3 times negative 1 plus 2? So this is going to be the absolute value of 1. Does that equal, that's going to be negative 1. So does the absolute value of 1 equal negative 1? No, it doesn't. So this is not a solution. This right here is called an extraneous solution. So you don't have to write extraneous every time. So I just cross it off that doesn't work and make sure I box in the answer that does work. Okay, the second one kind of moved into that space, but so again, I'm going to break it up into two parts. So I have x could be x plus 1, or x could be negative x minus 1. So solving for x, subtract x from each side, I get 0 equals 1, which, doesn't come up with a solution. That would be no solution. And then solving over here, I'm going to add x, and I get 2x equals negative 1. So x equals negative 1/2. So we can check x equals negative 1/2 and see if that works. So does the absolute value of negative 1/2 equal, because I'm plugging back into the original one, negative 1/2 plus 1. So the absolute value of negative 1/2 is 1/2, and this is 1/2. So it checks. So this is my solution. And for the last one, I want to, again, do two equations. So 2x plus 5 equals opposite of 3x, opposite of 4. So we haven't had a problem where this was a negative. So if this is a negative, make this a positive. So I'm just making them both opposites. And then also the original one, which is 2x plus 5 equals 3x plus 4. So I'm going to solve for both of them. So 5x plus 5 equals negative 4. X equals negative 9/5. And then don't box it yet, because remember you want to check your answer. And this side, subtract 2x. 5 equals x plus 4. X equals 1. So I'm going to check x equals 1 first. So just put it back into the original 1. Oops, that's an absolute value bar. So the absolute value of 7, this equals 7. So that checks. This one works. And then now I'm going to check negative 9/5. So 2 times negative 9/5 plus 5, does that equal 3 times negative 9/5 plus 4? This is just a little more work with fractions here. So you can always plug this into your calculator too as well, but I'm just going to use fractions. So this will be negative 18/5 plus 5. See what I did is I multiplied 2 times negative 9 and 1 times 5. And then I'm going to get a common denominator, so this is going to be 25/5. So this will be the absolute value of 25 minus 18 is 8/5. So the left-hand side will be 8/5. Okay, now I'm going to try to find the right-hand side. So this will be negative 27/5 plus 4. I'm going to get a common denominator and write 20/5, because 4 is the same thing as 20/5. So this will be negative 7/5. So these two are not equal. So that means my only solution is x equals 1 and negative 9/5 is extraneous.